exact values. So in my higher course, you're going to need to know some exact values without using a calculator. And it's these angles that you're going to need to know for sine, cos and tan. So for instance, you're going to need to be able to come up with, without a calculator, that sine of 30, well, if you pop in your calculator, you'll see you get the answer for half. Well, you're going to need to be able to have a way of coming up with that without using a calculator. So two ways of doing it. One is I'm going to fill in this table and we're going to find all of the sine, cos and tan values for all of these angles. And one way of doing it is simply to then memorize this. But my preferred method is going to be making a couple of triangles, which we'll come to in a second. Well, first of all, what of this can we fill in already? Well, if you know your sine, cos and tan graphs well enough, I'm hoping we can do 0 and 90 degrees right away. So we're going to picture the sine graph at 0 degrees right at the start. Where is it? It's at 0. So it starts at 0, the sine graph, and by the time it gets up to 90, it is at 1. So those are the exact values for 0 and 90. What about a cos graph? Where does a cos graph start, and where does it end up at 90 degrees? Well, it starts at 0 degrees up at 1, and it ends up at 90 degrees down at 0. So there we go, a few of us filled in already. And what about tan? Well, you may be less familiar with tan, but you may remember that tan goes right through the origin. So at 0 degrees, it is at 0. Now what happens when it gets to 90? Well, the tan graph goes along and it starts getting very, very, very steep. In fact, it goes up and makes what's called an asymptote, and you may remember a dotted line going up, and that dotted line is at 90 degrees. And what that means is it never actually gets to 90 degrees. At 90 degrees, there is no determined value. It just keeps going higher and higher, and we can't actually find a value for 90. So what we say is that tan of 90 is undefined. Okay, so now let's look at 30, 45 and 60. Well, let's begin with 45 degrees, how I like to think of a 45 degree angle. Well, the simplest way of making a 45 degree angle is to make a square and then chop it in half. So that's exactly what I do. So what I've done is I've imagined a square that measures 1 unit, 1 centimetre, whatever, by 1 centimetre, and I've chopped it in half, and I've got a 90 degree angle here still intact, and here I've got a couple of 45 degree angles. So if I want to find, for example, the sine of 45, well, I need to look at my triangle. SOHCAHTOA, sine is opposite over hypotenuse. Okay, so I'm going to need the hypotenuse. So I'm going to do a bit of Pythagoras. Longest side, 1 squared plus 1 squared is 2. So the longest side is the square root of 2. And don't forget that square root there. So now we can fill this in. Sine of 45 is opposite over hypotenuse, 1 over root 2. Cos of 45, 45 adjacent over hypotenuse is also 1 over root 2. And the tan of 45 opposite over adjacent, 1 over 1, well, that's just 1. So there we go, that's how we can find 45 degree exact values. So now what we need to do is find 30 degrees and 60 degrees. Now the good news is we can do this with the same triangle. What I'm going to imagine drawing 30 and 60, well, how do I make a 60 degree angle? An equilateral triangle will do a 60 degree angle. So I'm going to imagine drawing a 60 degree equilateral triangle, all three angles 60 degrees, and then I'm going to chop it down the middle, and that'll cut one of them in half. Now, it may be tempting to say I'm going to make it 1 by 1 by 1, but if I imagine drawing my triangle, in fact, let's draw it. This is not going to be particularly exact, but hopefully it'll be okay. There we go, and I'm going to chop it in half. Now imagine if it was 1, 1 and 1. Well, when we chop this in half, we'll be left with a measurement here of a half. Now I don't particularly want fractions in here, so what I'm going to do is I'm going to imagine that instead of making it 1 by 1 by 1, I made all of the sides 2 units or centimetres long, okay, and I chopped it down the middle. So when I do that, I end up with a nice right angle here. I've got my intact angle of 60 degrees. I've got 30 degrees here. Now what is this distance? Well, that was half of one of my sides. It was 2 by 2 by 2. This is just going to be 1 now. So remember, I make it 2 so that I can chop it in half and make it 1 here. Pythagoras again. This time it's not the longest side, so I'm going to do 2 squared, take away 1 squared. 4 take away 1 is 3, and again it's going to be root 3. So now I can fill these in, and I can fill these in for both 30 and 60. So let's start with 30. Well, my 30-degree angle is here, and I've got what looks like a 36. It's supposed to be a 30. Sine of 30, well, let's check this one first of all. Sine of 30, opposite over hypotenuse, 1 over 2, yeah. Cos of 30, adjacent over hypotenuse, root 3 over 2. And tan of 30, opposite over adjacent, 1 over root 3. Now for the 60 degrees, well, now I need to go to this angle here, and can I keep my finger here? Helps a little bit. Sine of 60 is opposite over adjacent, that's root 3 over 2. Cos of 60 is adjacent over hypotenuse, that one's a half. And tan of 60 is opposite over adjacent, that's root 3 over 1, or that's just root 3. Okay, so there we go, I filled in all of my exact values. So 2 options. 1 is memorize this table. 2 is draw the triangles. I prefer doing this because I think it's too easy to make a little mistake in here, whereas if you're really comfortable drawing your triangles, you can do them right at the start of each exam. If you practice it, it won't take you long, and you've got all the information there. Now, I'm going to mention a couple of ways, if you do choose to go down this way, to help you memorize it. Well, let's have a look at this here. Let's read through the sine values, okay? 0, a half, 1 over root 2, root 3 over 2, 1. Let's read through the cos values, but let's go backwards. 0, a half, 1 over root 2, root 3 over 2, 1. Can we see that these two are just the same, going in opposite ways? So if you were to choose to memorize a table, in some ways you only need to memorize sine, and you could automatically then figure out what cos is. So in particular, you could even focus on 45 degrees is the same for sine and cos. Maybe the next thing to do is focus on the nice values. So that sine of 30 is a half, that's a nice value, it's nice and easy, no roots. And cos of 60 is a half, so kind of opposites there, sine 30 and cos of 60. And then what you could do is you could then say, well, if you next try and memorize cos of 30, well, that's the same as sine of 60, so it's kind of a reverse thing going on here. Opposites of the same, opposites of the same, 45 degrees of the same. And tan, well, if you know that it involves root 3, if you memorize that 45 degrees is 1, if you know that 1 over root 3 is 30 degrees, think that it's less than 1, because tan's increasing all that way, then the next one is the bigger value, root 3. My overall advice is probably to go with the triangles here. Learn to do those when you've always got a backup, and what you'll find is you'll start to get comfortable with these if you use them often enough. Try and avoid using the calculator, even if it's a pain, try and keep using these. In the long run, it will make life a lot easier. Okay, so let's do a couple of examples using that. So first of all, nice quick one here, evaluate 2 sine 60. Well, so 2 sine 60 degrees. So really, all I'm looking to do here is try and remember or figure out what sine of 60 degrees is. So a couple of options, you can draw a triangle, 60, 30, 2, 1 and root 3, and you can figure it out from there. Or if you know it from memory, you'll remember that sine 60 is root 3 over 2. So 2 lots of sine 60 is 2 lots of root 3 over 2, which is 2 root 3 over 2. So remember, when we multiply fractions, we only multiply the numerator, so this becomes 2 root 3 over 2, which is just root 3, the 2's cancel. Okay, and for this one here, we're going to solve root 3 tan x plus 1 equals 0. We're going to solve this without a calculator. So first of all, let's rearrange this. I'm going to get to the point where I'm ready to put in my, where I would normally grab my calculator. Okay, so first thing to note is that you notice that there's a negative here. Now I don't put that in my bracket, I don't put that in my calculator. But I do reflect the minus here. So instead of doing tan and A, which I would do if tan is positive, I'm going to do C and S. So all I'm going to think now is what angle in that table gave me tan is 1 over root 3. So what I could do is I could try and think of which triangle uses the lengths 1 and root 3, and I would draw my 60-degree triangle. Now I could take a wee shortcut here if I could memorise it. But the triangle which involved root 3 in particular was this one here. So So I had a root 3 there and a 1 there and a 2 there. And that's 60 degrees here. Sorry for the scruffy drawing, and 30 degrees here. Okay, now, why didn't I draw my other triangle? Well, my other triangle, remember, only involves 1 and root 2, so that wouldn't have helped me with this. So I want the angle for which tan opposite over adjacent is 1 and root 3. In other words, I want an angle which has got 1 opposite it and root 3 next to it, opposite over adjacent. So there's my opposite. I'm going to go there first. So I'm expecting it to be 30 degrees. Let's double check. Tan of 30 degrees, opposite over adjacent, yep, 1 over root 3. So that tells me that my principal value is 30 degrees. Okay, so that's without a calculator. If you just know it by memory, then even better, you can just go straight there. And now what we're going to do is we're going to get our solutions. Okay, so that's 180 minus and 360 minus. Okay, final thing to do is check my limits, 0 to 360. Yeah, I'm happy with both of those.